As of 2020, there are 3,590 ski lifts in North America. People lose countless items by dropping them off of the chairlift every year. The average skier spends $200 on a pair of gloves. Poles are typically $50. When these items are lost via the chairlift, they can cost skiers lots of money to replace. Additionally, the extra waste negatively affects the ecosystem, which can negatively affect the ski resort's quality over time. To see just how big of a problem our problem statement was, we posted a survey asking 3 main questions. Do you ski or snowboard? What level skier do you consider yourself? And have you ever dropped anything off of a ski lift? The majority of our answers came from advanced level skiers or snowboarders, and majority, or about 58.1%, said they had, proving this is an issue that affects at least half of all skiers and snowboarders. To get a better idea of the common items being dropped off of a chairlift, we asked survey participants if they had dropped some of the following items off the lift. We also left another option for people to leave their own unique items they've dropped. The most commonly dropped items were gloves, poles, phones, and earbuds. The first solution we found to this problem was a gondola instead of a ski lift, but we concluded that gondolas are expensive and not ideal for skiers and snowboarders because they have to take off their skis or board in order to ride the gondola. So although it does solve our problem, it does so in a way that isn't cost efficient or convenient for its users. Another solution we found was the ski lift bubble. The issues with this solution is that the bottom area of the ski lift is still open so that the skier's legs can stay down, but this also means that items can still slip off the lift. Also, the bubble lifts are less aerodynamic than normal ski lifts, making them less efficient in high winds or strong weather, which is common for most ski resorts. So we set out to find a better solution. We knew we needed a solution that would be relatively cheap resource-wise. It must be able to catch anything from the size of an earbud to the size of a ski or snowboard. Should not get in the way of or affect user or users. Should not be heavily affected by the environment, specifically wind, cold temperatures, ice, and snow. It also must be durable in comparison to the weight of what it needs to catch or how sharp the object might be. It needs to not damage the items caught, and it needs to have easy access to the items once they have been safely caught. Each of us came up with 3 designs that met these requirements. We presented our ideas to the class and received feedback on them. After carefully reviewing our feedback, we selected our final design. We did not have access to a metal full-size chairlift to make our prototype with, so we constructed a scaled-down version out of PVC pipe and side paneling. Ideally, we wanted our solution to be able to attach to any chairlift. In theory, the back arms would be able to be welded onto any chair. We looked at how a real chairlift functioned, 2 wheels on either end with a metal wire wrapped around them, and based our prototype on the same design concept. When fully extended, there's a net underneath our chairlift that will catch any dropped items. We did several tests to choose the type of netting we wanted to use. First, we hung the net up outside and tested its durability by launching different skis and boots at it with different velocities. The net withstood the impact without damaging any of the items. Secondly, we left the net outside hanging for 1 month. Over this month, it experienced various weather conditions such as high wind, rain, snow, freezing temperatures, and sunny days. At the end of the month, there was no change in the quality of the net. The only thing that did damage the net was when it was exposed to a flame for too long. This caused a hole to be burnt through the net.
Ready?
Yeah. In our final design, these wheels would be motorized and would automatically spin while skiers load and unload the chairlift.